Hi, so in the previous video we looked at an introduction to polar equations, and we tried to give some details of how to identify what type of conic section we are dealing with from the polar equation, as well as knowing the orientation, and we derived one of the equations, which is this one right here. That's what we came up with. If you didn't check that video, check out the link in the description. Watch that video before you watch this one. It will give you an overview of everything that you have to know about polar equations. So we'll now try to look at some few examples that have to do with polar equations. Okay, so the question is just basically asking us to discuss. When the question says discuss, just keep in mind to say you have to give every detail necessary um, for that particular conic section from that polar equation. So let's say you're given r is equals to 12 divide by 4 minus 8 sine theta, like that. Okay, so now if you observe, first things first, considering the fact that I have sine, I know to say I'm oriented on the y-axis, but I cannot yet conclude to say whether it's an ellipse, a parabola, or a hyperbola, because I don't yet have the value of what the value of the correct value of e here, because this is not a 1. Okay, so what I'm going to do right now is I'm going to multiply, or maybe instead of me using multiplication, just the word multiplication, let me do it the easy way, where you can what you this is something that you can do for in all the cases, where you just factor out the 4, or just force it outside if you're unable to factor it. That's a 4 here, then you're going to have a 1 minus a 2 sine theta. So what I'm basically saying is that do everything possible here, but don't change the meaning. And if you observe, I haven't changed the meaning, so my r is equals to, so here you have like 4 into 4 is a 1, 4 into 12 is a 3, so you have like your 3 divided by 1 minus 2 sine theta. Oh wow, there we have it. That is our what? Our simplified polar equations. We have 3 divided by 1 minus 2 sine theta. Okay, so now what I have is this. Okay, so from this I can now identify the type of conic section that I'm dealing with, looking at the value that I have here, which is a 2, and we need to say if our e is greater than 1, okay, of which it qualifies for that one. Since 2 is greater than 1, then we are dealing with a what? With a hyperbola. Okay, so this is something that is very basic. I believe we understand now. Okay, so now what I would love to do is that I don't want to graph it using this equation. I want to use the Cartesian equation. So what I'm going to do is that I'm going to convert this to Cartesian, but you might want to see how you can graph it using this same one. That is something that I'm going to do after I graph it, or I give the details from the Cartesian equation. Okay, so here for me to convert this to Cartesian, it's pretty simple. It's just more like we're answering a question. We're also adding some other techniques, such as converting from polar to Cartesian, which you might need even on other questions as well. So here you just cross multiply, so you're going to have your r multiplied by 1 minus 1 minus 2 sine theta is equals to 3. So having known to say we're dealing with a hyperbola, even when we convert, we should expect to get a hyperbola here. So I'll distribute the r. You have your r here minus 2r sine theta is equals to 3, like that. Okay, so keep in mind to say when you're converting from polar to Cartesian, remember to say your x is equals to r sine, sorry, your x is equals to r cos theta. That's the opposite. R cos theta. Your y is equals to r sine theta. Then your r is nothing but the square root of x squared plus y squared. This came from r squared is equals to x squared plus y squared. I've just made r the sub of the formula here. So that's what I'm going to put right here as my what? As the square root of x squared plus y squared minus 2y, because r sine theta is equals to y, so that's going to be 2y there is equals to 3. So the square root of x squared plus y squared is equals to, I'm going to have a 3 plus 2y. Okay, and to get rid of the square root, you just square both sides. This ends up to be x squared plus y squared is equals to, that's going to be a 9. That'd be a 9 plus 3 times 2 is a 6 times 2 giving us 12, so 12y, then that would be plus 4y squared. Okay, so you observe that this is in form, this is just more like a general, um, that's the general equation. From this general equation I have to complete a square for me to get the standard equation, and I should expect to get a hyperbola. So I have my x squared. When I bring the 4y this side, is going to be y squared minus 4y squared, which is going to be minus 3y squared. Okay, then I'll have minus the 12y is equals to the 9 that I have here, and the 12y, when it goes that side, becomes negative. I've written it there. Okay, so we are completing the square. So what I'll do is that I'll say x squared minus, I'm factoring out the 3, that would be a 3y squared plus 4y is equals to 9. So you're going to have x squared minus 3. Then if I take completing the square for this part step by step, I'm going to have like y squared plus 4y plus minus 2 squared minus minus 2 squared. I've just multiplied the b term, which is the 4, by minus 1 over 2. That's why I'm getting minus 2 there when I multiply the 4 by minus 1 over 2. Okay, which is something, which are the steps that we follow when you're completing the square. So this is equals to 9. So you're going to have x squared minus 3. So this is going to be y, this plus that you have here, plus the 2, which is that 2, then squared minus 2 squared, which is going to be a 4. I've gotten it from that one. Then this is equals to 9. So you can distribute the minus 3. That's going to be x squared minus 3y plus 2 squared plus 12 is equals to 9. So before I even continue, considering the fact that this one is its sign, we expect it to be oriented on the what, on the x-axis, sorry, on the y-axis. So we should expect the y variable to be this side, as in supposed to be y minus k squared divided by a squared minus x minus h squared divided by b squared is equals to 1. We should expect the y to be on this side. So let's see how this is going to end up to be. Okay, so now this is going to be like x squared minus 3y plus 2 squared. This will be equals to 9 minus 12, which is minus 3. Okay, which is equals to minus 3. I'm going to divide both sides by minus 3. Okay, minus 3 there and minus 3 there. So this part, we have a negative, and the negative becomes positive, and that's a 1. So that's just going to be y plus 2 squared, and this is going to be minus because of the 3 there. You have x squared divided by 3 is equals to 1, which makes a lot of sense that this is the equation of the hyperbola. That's the standard equation of the hyperbola, and if you have a y here, it simply tells you that you're oriented on the y-axis, and that's what we have. Okay, so having found the standard equation, which is y plus 2 squared minus x squared divided by 3 is equals to 1. Let's now try to find every necessary detail about this this hyperbola. Of course, we know the center now is supposed to be at h comma k. Our h value is 0, our k value is minus 2, like it's minus 2 there. Okay, then what else do we have to find? We have to find we have to find the focus. But before I do that, it's important to note that my a squared is equals to 1, then my b squared is equals to 3, then c squared is just equals to a squared plus b squared, which is a 4. So meaning c is equals to positive or negative 2. Okay, then my a is still 1, positive or negative 1. My b is equals to positive or negative root 3. So if I go to the focus, so the focus or the foci, since it's on the y-axis, it's supposed to be h comma k positive or negative c. So I'm going to say my f. So in this case, our h is 0 comma k, which is 2 minus 2, plus or minus c, which is a 2. Okay, but keep in mind, when we are introducing this, we said one of the focus of polar equations is at 0 comma 0, so we should expect one of the focus to be at 0 comma 0. So here we have it. So we can say our f1 is going to be 0 comma, it will be minus 2, that's going to be minus 4. Our f2 is going to be 0 comma minus 2 plus 2, that's going to be a 0, and this makes sense that it's at one of the focus is at 0 comma 0. Okay, so what about the vertices? So the vertices, they have the coordinates. They're going to have like h comma k plus or minus a. Okay, you're going to have your v, your h is 0 comma, your k, which is minus 2, plus or minus a, which is a 1. So that's going to be v1 at 0 comma minus 3, that would be minus 2 minus 1. Then v2 at 0 comma minus 1, that would be minus 2 plus 1. Then let's look at the co-vertices. For the co-vertices are going to be on the x-axis. Okay, co-vertices, they're going to have the coordinates h plus or minus b comma k. So our h in this case is 0, so I'm just saying plus or minus b, which is root 3 comma k, which is minus 2. So co-vertex 1, so I'll just say cv1 is going to be minus root 3 comma minus 2. Then cv2 is to be root 3 comma minus 2, like that. Okay, so what else do we have to find? We have the focus, we have the vertices, we have the co-vertices. We also have to find the asymptotes. Okay, so for the asymptotes, we say it's y minus k is equals to positive or negative b over a. Then here we'll have like x minus h. Okay, so this is going to be y minus k, which is just going to be minus 2, like y minus 2, which is going to be plus 2, is equals to positive or negative our b is root 3 divided by a, which is a 1, so it just be like that. Then h is 0, so just going to have x here. Okay, so meaning for our asymptotes, one of them is y is equals to minus root 3x minus 2. Another one is y will be equals to root 3x minus 2. Okay, so another thing that I observe we have to find is the intercepts, because this is not centered on the origin, so it's obvious it might maybe cut the x-axis at some point. Okay, it might cut the x-axis at some point. So now let's see what we are going to get here. If I want to find the x-intercepts, okay, if I want to find the x-intercepts, so there's no guarantee that we might really cut the x-axis at some point, but let's just give it a try. Okay, so now for this one, if I want to find the x-intercepts, I'm going to set this y to be equals to 0. So I'm just going to have like 0 plus 2 squared minus x squared divided by 3 is equals to 1. So that's going to be 4 minus x squared divided by 3 is equals to 1. So this is just going to be more like minus x squared divided by 3 is equals to 1 minus 4, giving us minus x squared divided by 3 is equals to minus 3. The negative goes, you have like x squared is equals to 9. Okay, so meaning x is equals to positive or negative, is equals to positive or negative 3. So x you have x to be equals to minus 3 and x to be equals to 3 for the intercepts. What about the y-intercepts? I doubt if I have anything in the y, but let's just try anyway. So if we make this one to be 0, so meaning you expand this part, that's going to be y squared plus 4y plus 4 is equals to 1. So that's going to be like y squared plus 4y, that's going to be plus 3 is equals to 0, because you bring this one on the other side. Okay, so that's going to be y squared. When you factorize, that's going to be plus y plus 3y plus 3 is equals to 0. Oh wait, we might really have something here perhaps. So that's going to be say y plus 1, 3y plus 1, that's going to be y plus 3 and y plus 1, of which we are talking about having y is equals to minus 3 and y is equals to minus 1. Wait, this is actually interesting because the y-intercepts, considering the fact that your h is 0, your y-intercepts is just nothing but this minus 3 here and this minus 1 here, which are our vertices there. Okay, these are our vertices and these are what our core vertices. So it makes sense that we cut the y-axis at some point, but that's just more like the turning point of our graph, which is those there, which is actually cool. So it's just more like a unique way of finding the vertices without having to look at the coordinate system and all those things. It's actually interesting. Yeah, I would want to try to get details using the polar equation itself. We see what you're going to get. We say it was r, okay, r was equals to 3 divided by 1, that was plus or minus, that was minus 2 sine of theta. Okay, so what I would want to do, let me try to get the vertices just using this what I have here. So for this one, you're going to have to put your theta here and your r there. So your r is your dependent variable, your theta is your independent variable. Your r depends on your theta. So what it is that since I'm dealing with sine, meaning I'm on the y-axis, like I'm going to have to look at the angle, which is 90, as well as 270, which is 3 pi over 2. So if I put 90 here, which is pi over 2, and 3 pi over 2, how is this one going to be? Okay, so if you say sine 90 is a 1, so you're talking about 3 over 1 minus 2, giving you what? 3 divided by minus 1, which is giving you what? Minus 3. So you get minus 3 here. So let's talk about sine 270. So sine 270 is like minus 1. So it's to be more like 3 divided by 1 minus 2 multiplied by minus 1, giving you a 3. No. A 3 divided by 3 actually. Then you get the 1. You get the 1 there. Okay? So that's what you get in terms of r, but I want to get it in terms of y since I'm on the y-axis. So this is just going to be y. We know that y is equals to r sine theta. I'll say y is equals to, what's my r? Minus 3 sine theta. What's my theta? 90. Sine 90 is a 1. So this still remains to be what? To be minus 3. Minus 3 here like that. Then y again is equals to r sine theta. So y is equals to your r is a 1, then sine what? Sine 270, which is minus 1. So you get minus 1 instead of a positive 1. So this is what you get. This is the minus here, which is here, and the minus 1, which is there. Okay, so that's another unique way of of getting your vertices. And everything else, the focus is very easy to find, but I'll not really go in that way, since we have already like a unique way, or like a simple way to find everything else by converting it to Cartesian. Okay, so we can go ahead and graph this. Okay, so here we have as our x y axis, and this is our x axis. So for the center is at 0 comma minus 2. So if this is minus 1, let me put minus 2 there. Let me name that as my center. That's our center right there. Then our focus, one of them is at 0 comma 0, another one is at 0 comma minus 4, which would be, let's say, minus 3 there and minus 4. So we have another focus at this point. So you can say this is our f1 and that is our f2. Let's go to our vertices. One of them is at 0 comma minus 3, which is one here. I can say this is my v1. Another one is at 0 comma minus 1, which is this point. I can say that's my v2. Okay, then my cv1 and cv2, they're just going to be somewhere here. It's going to be somewhere there, like that. Okay, so I can place another one on this side. Okay, so that's where we have them as our core vertices. So what you do is that you can just draw a line passing through v2. Okay, not really that visible. Then another one passing through v1, going to meet this line that is coming from the core vertices. Then what you do is that you just draw a straight line passing through this point, passing through those two corners. Another one that